So we talked about density yesterday, and we said that there was a formula for calculating density, which is density equals mass divided by volume. Okay, so that is your primary formula right here. Density equals mass divided by volume. Now, if you're good at algebra and you're good at solving for a variable, that's the only thing you need to know. Density equals mass over volume, because then whatever variable you're solving for, that just becomes your X, and then you manipulate the equation appropriately. However, if you are not a fan of algebra, you may prefer to use what we call the density triangle. Okay, and the density triangle is right here. And here's another version of the density triangle if this one confuses you. I'm going to show you a video that shows how to use these density triangles, or at least this one, which is similar to that one, to manipulate the formula so that you can solve for your given variable. Okay. Now, the key to these triangles is you have to remember that M goes on the top of the triangle, and then D and V go on the bottom. It does not matter what order you put those in. I like to remember M goes on top because I think of the fact that my mom was the one that was in charge when I was a kid. So that's how I remember it. Mom's in charge, so mom's the head of the household. But if that's not your situation, then that might not work for you. So you have to figure out how to remember that triangle goes that way. Okay, so I'm going to show you this video. And again, this is the surefire way to never manipulate your equation wrong, in case you're not real comfortable with the algebra. And then we're going to practice.
How to solve density.
Now, before I get too into this, couple things. Number one, she doesn't pay attention to sig figs at all. Okay, so don't pay attention to that. Just pay attention to the setup. The second thing is, in a couple situations, there's some units missing. So we're going to pause and talk about those a little bit because the units are very important.
Density Problems Using the Density Triangle by Caroline Shea. Before we do anything, it's important to note that this is the division line and this is the multiplication line. So when anything passes through this area, it's multiplying, and when anything passes through this area, it's dividing. So from this information, we know that we're finding the density and we're given the mass and volume. Since we're finding the density, we can start off by doing D equals. What's left is mass and volume, and what connects them is the division line. Because we use the density triangle like a book, we use it top to bottom, meaning we're going to start in the mass and then go to the volume. So we're going to divide mass, because of the division bar, by volume. So density equals mass divided by volume is the formula. So the mass is 69 grams, so we can place that in for M. And the volume is 50 milliliters, so we can place that in for V. So now we just have to do 69 divided by 50, and when you do this, you get an answer of 1.38. So far we have that the density is 1.38, but we're not done because we still need our units. So we're going to take the grams from the mass and the milliliters from the volume, making the density 1.38 grams per milliliter.
Okay, so remember your density volume simply comes from the mass and volume density, or your density unit comes from your mass and volume. So because we had grams as our mass and volume as our density, we simply divide those just like we did with our numbers.
So now we're going to find the volume of the wood because we're already given the mass and density. We can start off by doing V equals because we're trying to find the volume. So now we just have to find the relationship between the mass and the density on the density triangle. Because they're separated right here, this is the division line, so we're going to be dividing them. And if you remember, we go top to bottom, so we're going to start with mass and divide by density. So we can do mass over density, or volume equals mass divided by density. Because we already know what the mass is, 7 grams, we can put that in for M. And because we know the density, which is 0.07, we can place that in for D. And when 7 is divided by 0.07, there is an answer of 100, so the volume would be 100. But we still needed the units. Because volume is typically measured in milliliters, we can now add milliliters.
Okay, I'm going to stop this again because you can't just assume what your volume unit is going to be, okay? You will actually be able to find this from the information in the problem. You will notice here that she does not have a unit written after her density. That is something that you will have. Okay, so let's assume in this case our density was grams per milliliter. She randomly pulled milliliters out of the air as her volume unit, but you must look at your density to figure out what your volume unit is. Because remember, density is just mass divided by volume. So this top piece needs to match your mass unit. The bottom piece here needs to match your volume unit. So in this case, if she came up with milliliters, that would have had to have come from the second part of the density unit. Okay, so if this had been grams per centimeters cubed, then volume would have been centimeters cubed and not milliliters. Okay, so you must look at your unit in the problem to figure out what your true unit is. Okay, she made an assumption that she couldn't make.
The volume is 100 milliliters. So we're now finding the mass of the mercury, and we're given the volume and density. So we can start off by doing M equals because we're trying to find the mass. What's left is the density and volume, and the relationship between two is the bar right here, which is the multiplication bar. So we're going to be doing density times volume. So mass equals density times volume. Because we know the density, 13.6, we can put that in for D. And we know the volume, 30, so we can put that in for V. So when you multiply 13.6 times 30, you get an answer of 408. So mass equals 408. But we still need units, and because mass is often written in grams, we can write 408 grams.
Okay, so here again, she's saying mass is often written in grams. Remember, that could be kilograms, milligrams. Okay, so again, you can't assume. This time she did give us a density unit. So you will see here that, where did my annotate go? You will see here that our density is grams per milliliter. The milliliters match our volume unit. The grams must match our mass unit. So in this case, it is in fact grams. Okay, but if that had said milligrams per milliliter, we would have needed milligrams as our mass unit. Okay, so you need to pay attention to whatever it gives you in the problem. All right, we are going to stop the video there. And you may now go into pages 13 and 14 in Classkick. Oops. And I'm going to go over the first problem with you. Okay, so again, you can leave mine up or you can just follow along on your page.
Bye, Mrs. McCord.
Bye, Isabella. Okay, so question number 1 says, what is the density of a piece of iron that has a mass of 16.2 grams and a volume of 2.08 centimeters cubed? So the first thing you have to do is you have to identify what you know and what you're trying to solve for. Okay, so this is a word problem. So we know we're dealing with density, mass, and volume. I've highlighted the important pieces here. Okay, it's saying what is the density of a piece of iron that has a mass of 16.2 grams, volume of 2.08 centimeters. So we can see here that we know our mass and we know our volume. That means we are trying to find density. So the first thing we have to do is figure out which formula we're going to use. If you are using your algebra, you already have density equals mass over volume. Okay, that's the base formula. If you are using your triangle, we know that M is on top, G and V are on the bottom. So the first thing you have to do is pull out the variable that you are trying to solve for. And in this case, we're going to take our D and we're going to pull it out and make it D equals. Okay, so now everything that is left makes up the rest of your problem. In this case, we have M with the dividing line over top of V. So that is how we get that formula from the density triangle. Now we just need to plug in our values. Density equals mass is 16.2 grams. I'm going to leave the units off while I'm doing the math, just so you don't get confused. We'll talk about the unit at the end. Volume is 2.08, so that goes on the bottom. We're going to solve that by taking 16.2 divided by 2.08. Now, the calculator gives us 7.788461, etc. Okay, now, in the video, she didn't pay attention to sig figs, but we know that in our class, we need to follow our sig figs rules anytime we do math. So because we did division here, we need to go with the least number of sig figs in the problem. Here we had 3 sig figs, here we had 3 sig figs, so our answer needs 3 sig figs. Here's our first sig fig, second, third, and if we cut off after that 8, we must look at the next number, and we know that we have to round up to 7.79. So there is the number portion of the answer, but you must also include a unit. So in this case, we need a density unit. If you double check up top under our common units, you can see that density is a mass unit slash volume unit. So it's a mass divided by a volume. We need to use the units that we used in our problem. So in this case, our mass unit was grams. So that's going to be the top part of our density unit, divided by our volume unit, which in this case was centimeters cubed. So your final answer is 7.79 grams per centimeter cubed. I have not separated the units out in the boxes this time. Okay, so I'm going to bring up the key just so you can see how your answers need to look. You need the number portion, so 7.79. Then you can choose to put a space in or not. Okay, that's up to you. Then you need gram slash centimeter, and then the cubed is just going to go right after it as a regular number. Okay, so either of those, it'll give you the correct answer for. Okay, so what you're going to do now is you're going to work on pages 13 and 14. You can skip 3B for now, unless you know the answer. We'll talk about that in a couple minutes. And you can also skip the very last problem on 14, which has to do with something called volume displacement. We'll talk more about that over the next couple of days. So 3B relates to 3, and it asks if this sample, which has a density of 8.2 grams per milliliter, will sink or float in water. So here's the thing with density. If an object is more dense, it will sink than the object than what it's in. So because water only has a density of 1, and that's a number that you need to memorize, okay? That's a tough one, 1. Density of water is always 1. If your density is higher than 1, then it's going to sink. If your density is less than 1, like 0.5, 0.6, then it's going to float. So in this case, tin has a density of 8.2. Since 8.2 is higher than 1, it's going to sink. So the way you would answer this would be, it will sink. And the reason is because 8.2 grams per milliliter is greater than 1. And that's because that was the density of water. Okay, so that's the only way you need to support it. Okay, so more dense objects sink, lighter, less dense objects will float. Okay, you can spend the rest of the time